Here are some examples of ways that we can write functions as each other. So I've got a few problems written down here. The first one is to write the tangent of theta plus the cosine of theta in terms of the cosine of theta. Well, first of all, I'm going to use one of the fundamental identities on the tangent and call it sine theta over cosine theta plus cosine theta. Okay, I didn't have to change that one. The second thing I've got to do, though, is I've got to do something with that sine, and sine is not equal to cosine. In fact, the only thing we know about sine is that sine squared of theta plus cosine squared of theta equals 1. Now, don't start making up algebra rules because we can't, but we could write the sine squared of theta as this. We could write it as the sine squared of theta equals 1 minus the cosine squared of theta, because that we just subtracted over. Then we can take the square root. So we can take the square root of this, and we can take the square root of this. Now officially, algebraically, we have to do plus or minus, so that's fine. But now we get the sine of theta equals either plus or minus the square root of 1 minus the cosine squared of theta. So now I can rewrite it in terms of cosine. I know it's got radicals and all kinds of stuff, but the only function in it is cosine. So this now is going to be written, instead of sine, I write plus or minus the square root of 1 minus the cosine squared of theta, and no, that does not simplify. I wish I could make up algebra rules, but I can't. It's divided by the cosine of theta, and then I add plus cosine of theta. So every function in here is cosine. So we wrote the tangent of theta plus the cosine of theta in terms of the cosine of theta. I know it doesn't look great, but it is what they told us to do. So that's something that you'll run into in section 4.1. Second problem here, I've got secant of theta plus sine of theta in terms of cosine of theta. Well, this one's easy using a fundamental identity because it's 1 over the cosine of theta. But then we've got plus the sine of theta. But it's the same as this one up here, so I'm just going to use my results that I just got. Sine of theta is plus or minus square root of 1 minus cosine squared. So this is going to be equal to 1 over the cosine of theta plus 1, plus or minus. Let me just get rid of this and just say plus or minus, and then square root of 1 minus cosine squared of theta. So there's 1 over cosine of theta, which is secant theta, plus sine theta. Sine theta is plus or minus 1 minus cosine squared of theta. So we're done. Okay, that one's not too tough. Next one, write tangent plus cotangent in terms of tangent. Well, one of our fundamental identities was that the cotangent was equal to 1 over the tangent. So I'm going to write tangent theta plus 1 over tangent of theta. And look at that. We've got it all written as tangent. So that one was easy. Some of the ones you run into in this section will be easy.